In this tutorial, we're going to look at how to create names and chemical formulas for simple ionic compounds. And these are also called binary compounds, binary ionic compounds. Binary, of course, you'll recognize, and it means two. So these are ionic compounds with two parts. You recall this would be a sheet that you would have received in class, and what we're going to do is we're just going to go through a couple of them just to see how you're making out. So we'll minimize that, and we'll start with the first one, which is potassium fluoride. We are going to be looking at this periodic table, and it's the same one you would have received in class. So I'm going to look up potassium, number 19, and fluoride over here, which is, or fluorine, which is number 9. So all of the tutorial is really going to be done with me having the sheet here and looking at it, but you have your sheet, and so you can follow along. So I look up potassium, I see its symbol K, so I'm just going to write K, and fluorine, fluoride, is a capital F. And recall from the last tutorial that we know that fluorine has 7 valence electrons, so we'll just draw those in, and potassium has a 1 valence electron. So kind of a perfect match. So potassium can donate its electron here to fill its outer ring, and it can drop down and have a full ring as well. So we just need one of these to make this whole arrangement happen. So just write that again, potassium and fluorine. Second way would be to look at your periodic table and see that potassium is in group 1, so it has a +1 charge, and fluorine is in group 17. It has a -1 charge. Let's go back here. Remember, these are all +1, all of these ones, these are +2. When they lose those electrons, these are all -1, because they just need one more in order to become like the noble gas. These guys need 2 to become like the noble gas. And similarly, these -3, minus +4, depending on what it's bound to, and these are all +3. Now, all of these ones in here, you're going to have to look at the charge given. It's like, so if we look at manganese, it has a +2 or a +4, and you just have to look at your periodic table to find that out. And we'll talk more about these ones later. So let's get back here. So if we know this is a +1 and this is a -1, you ask yourself, how many of each of these do I need to make this whole compound neutral? Because that's the goal. And it's one of each. So you have KF. So that's the answer to the first one. Over here we'll do B, which is barium chloride. Alright, so I'm looking at the periodic table, I'm finding barium, there it is, Ba, and it's in group 2, so I know it's going to have a +2 charge. Chlorine, look at it, Cl, and it's in group 17, so it has a -1 charge. It has 7 valence electrons, so close, if it could just get one more, it would look like the nearest noble gas. So when it does, it becomes a -1. So then I ask myself the question, how many of each of these do I need to make the compound neutral? And of course, if this is a +2 and I just put a chlorine with it, I still have a +1 charge. The -1 +2 gives you a +1. So to fix that, I'm going to put 2 of these. I'm going to just add another Cl -1. So these 2 together will give me a -2, and this one will give me a +2. And that, of course, is neutral. So we can write it like this, BaCl2. I'll show you another one and give you another method to actually taking words and putting them into chemical formulas. So C is silver chloride on your sheet. Silver chloride. And I guess this is not the best example, but it will still work. Silver we find in the periodic table is Ag, and it has a +1. It's a transition element, so you're going to have to look at the periodic table to find it. Ag is right here, and tells you it's +1. Chlorine's over here, and it's a -1. So chlorine is Cl and a -1. Now, the other method I wanted to make sure you knew how to do was called the crisscross method, and that is to just take the number that's associated with the charge and put it after the second one, and take this number and put it after the first one. So it's crisscrossing, and so you just have Ag1 Cl1 or AgCl. Let's try this with a more apparent one. I'll just make one up like aluminum and oxygen. So aluminum, you look it up, it's in group 13. It has a charge of +3. So it wants to give away those 3 electrons. Oxygen is in group 16, right over here. So it would have a -2 charge. So we'll just put -2. And here's the crisscross method. So you just take the 2, that's over top of the oxygen, and you put it after the aluminum. You take the 3, which is after aluminum, and you put it after the oxygen. So you have Al2O3. So that's kind of another way you can do this. Again, but you could still do it the first way that we learned, which is how many of each do I need to make it neutral? And you can see, well, if you just put them together, you're at +1. And so how do you fix it? You add another oxygen, and then you're minus, and then you add another aluminum, and so you add another aluminum, and you get plus, and then you can go back and forth. Or you can recognize also that 3 and 2 have a common factor of 6. And so how do you make 6? Those of you that like math will like this one. So how do you make a +6, and how do you make this a -6? So because all compounds are neutral. So of course, +3 times 2 would give you a +6. And how do you make this? Well, O times 3 would give you the -6, and then you just have your compound here, Al2O3, aluminum oxide. In the second part of this tutorial, we are going to look at how to convert chemical formulas back into names. And for this, we're just going to do a few rules. So naming ionic compounds. And let's just see what the first one is. The first one is ZnF2. ZnF2. All right, so the first rule, the first thing you can do if you're a step-by-step person is to name the metal. And this would, of course, be the positive part of this compound, and that's the metal, and we can call that zinc. We look it up in the periodic table. Zn would be zinc. And 2 is to name the nonmetal. Remember that ionic compounds are made by the union of a metal and a nonmetal. They transfer those electrons. They become positive cations and negative anions. So let's just use blue to represent the negative part of this compound. And we'll name it fluorine. And the third and final is to change the ending of the nonmetal to IDE. So this INE would be changed to become IDE, and we will get our fluoride. And so altogether this compound is called zinc fluoride. I'll just give you a quick little quiz here. Name this compound. Okay, first part is aluminum, and And the second part is nitride. Not aluminum nitrogen, aluminum nitride. Let me give you another one. Magnesium fluoride. Okay, how did you make out? Good. Keep practicing using those sheets, and if you have any questions, please come and see me.